Today we are going to talk about solving linear inequalities. So our learning goal is to be able to solve both single and compound inequalities, and not only to do that, but also to be able to graph their solutions. So graph their solutions as well as solving them. So you did these in Algebra 1, but just a couple hints to help you remember. When we are dealing with inequalities rather than equations that have equal signs, we're obviously going to have a less than symbol, a greater than symbol, less than or equal to, greater than or equal to. And when you have these, we have a couple special things we have to remember. First, when you multiply or divide by a negative number, you must remember to flip the symbol. So if it started out as a less than sign and you divide by a negative, you have to change it to a greater than sign. So remember to flip the symbol when you multiply or divide by a negative number. The other reminder is for how to graph. Once you have the solution, so let's say you have x is greater than 5. You have to put that solution on a number line in addition to listing it algebraically. So when you're graphing, remember that you're going to put circles around the numbers. The less than and greater than symbols need open circles, while the less than or equal to and the greater than or equal to symbols need closed circles. Now the way that I keep that straight in my mind, it might not help you, but it helps me, is to remember that these two symbols right here have something extra. They have that little equals at the bottom. So I remember that when I'm drawing on a number line, I need something extra, and that is to fill it in. So when you have the equal sign underneath, you have to fill in your circle, and hopefully if you didn't already remember that, that'll help you out. Okay, so let's look at a couple examples that are going to help us to meet this learning goal here, to solve the inequality and then graph the solution. So we're going to solve it first, and with inequalities, it's important that you always move your variable to the left side. So we want the variable on the left, and in fact that makes me remember that I should probably write down one more hint, and that is that if you have to switch the variable from right to left, so if you accidentally get it on the right side instead of the left side, you have to flip the symbol, which is why we prefer to just get it to the left side so we don't have to worry about that. So if you switch the variable from right to left, we have to flip the symbol as well, just like we would if we had to multiply or divide by a negative. So let's work on getting it on the left so we don't have to worry about that. So here, if I want my variables on the left, that means I need to move this 10x that's on the right by subtracting it on both sides. So I'm going to get rid of that. So on the left side, I've got negative 3x plus 9 is greater than or equal to, and then negative 12 is what remains on the right. All right, so now if I've got all my variables on the left, that means I need my constants on the right. So I'm going to subtract 9 on both sides to get rid of this. So I've got negative 3x is greater than or equal to negative 12 minus 9 is negative 21. So the only thing I have left to do to get the x alone is to divide by negative 3. So when I divide by negative 3, I've got x. Then there should be like a red flashing light going off in your head right now that tells you I divided by a negative, so I have to flip the symbol. So less than or equal to, and then negative 21 divided by negative 3 is positive 7. So my algebraically written solution is x is less than or equal to 7. Notice my directions say to also graph the solution. So when you do a graph of the solution, all the number lines that I give you are going to have two numbers. If you only have one number in your solution, that means that 0 needs to be the other one. 7 is bigger than 0, so 7 is going to go over here. 0 over here. We need to choose the type of circle, and then we need to choose the direction of the shading. So since there's a equals underneath the less than sign, that means I need a closed in circle. So I'm going to close in a circle on the 7, and my shading then is going to go to the left, less than left, and the point should also help you with remembering what direction to go, because this little point right here is pointing to the left. So there we have covered both of our requirements that the directions give us. So now I want to go on to the next one. Now notice that the learning goal said single and compound inequalities. So on this one, I am going to have a compound. This is called a conjunction. I call them sandwiches because your variable is going to end up sandwiched between two other numbers. So to solve this one, we kind of have to apply that whatever you do to one side, you do to the other, you have to do to two other sides because we have two other symbols. So if I want to get W alone in the middle, I need to subtract the 4. Again, everywhere there was a symbol, I have to subtract that 4. So this goes away. On the left side, 9 minus 4 is 5, so I got 5 is less than negative 1/2. W is less than 10 minus 4 is 6. Okay, W is still not alone. I need to get rid of that negative 1/2 that's multiplied, so I need to multiply by the reciprocal to get rid of a single fraction like we talked about in the last lesson. So multiply by negative 2, multiply by negative 2, and multiply by negative 2. So 5 times negative 2 is negative 10. I multiplied by a negative, so I have to flip the symbol. Those cancel out, so W is alone. Over here, I also multiplied by a negative, so I have to flip that symbol as well. 6 times negative 2 is negative 12. Now, with a conjunction or a sandwich, when we write our final answer, we need it to be in number line order, and this one is not. Negative 10 is a bigger number than negative 12. So the way to know this is that if you've got greater than symbols, just flip everything. So I'm going to flip these positions here, which means I flip my symbols. You always need it in number line order. So your conjunctions, we are always going to write with less than symbols. Now here, I said we would always graph with two little hash marks, two numbers. There are two numbers in my answer there, so I'm going to put both of those numbers here, so you don't need to put 0 anywhere. There was the algebraic solution. So now on the graph, these are both less thans, which means they are open circles on both the negative 12 and the negative 10. A sandwich, I call it that because it's sandwiched between, which means the shading should also be between. So the shading should be between those two open circles. All right, last inequality. This one is also compound here. It wants us to solve it with an OR. These are called disjunctions. And what I'm going to do here is I'm going to solve each of them. So the OR is part of the answer, so don't forget that in the final answer. So first thing it wants here is it wants me to get rid of that added 7 by subtracting. So I'm going to subtract 7 on both sides there. Now again, this is an OR, so it's separate. So I'm solving this first one first. So negative 2y is less than negative 4. Then I need to divide by negative 2. Again, when I divide or multiply by a negative, I flip that symbol. So y is greater than positive 2. Again, I'm going to have an OR in my final answer. So now I go up to solve the other part. So I solve it first by subtracting 5. So that gives me 3y is less than negative 3. I divide by 3. These cancel, and so I have y is less than negative 1. So I have y is greater than 2 or y is less than negative 1. So that's my algebraically listed answer. Now I need to graph it. So 2 slash marks, the lower number is -1, so put that down here. Put 2 up here. And now those should both be open circles. There's no equal signs with the symbol. The one with -1 was a less than, so less than means left, so go this way. Don't forget to shade the arrows because all those numbers going on forever are less than -1. Y is greater than 2, so that means bigger than 2. The shading would go this way. And when you are solving a disjunction, which is the fancy word for these OR ones, the shading should always go out to the arrow ends. If it doesn't, when you go to actually look at your solutions here, the y greater than 2, if it wouldn't be going out to the ends, if you would have overlap, that would mean that you've got something wrong, because all of the ones we're going to solve, the disjunctions go out to the arrows. So make sure that your graph matches up with that, and make sure your algebraic answer matches up with that as well. All right, so hopefully that refreshes your memory on the inequalities that you learned in Algebra 1. Here we've got a word problem, so an application of using inequalities. It says a professor announces that course grades will be computed by taking 40% of a student's project score and adding 60% of a student's final exam score. If a student gets an 86 on the project, what scores can she get on the final exam to get a course grade of at least 90? So the part that makes this an inequality is the at least. At least means 90 or better, so greater than or equal to 90. Now it says 40% of means to multiply, so 40% is 0.4. Of means to multiply. We're going to multiply it by, it says the student's project score. And in this case, we are told that the student gets an 86 on the project. So 40% of the project score. And adding, so plus 60%, 0.6, of the student's final exam score. Well, we're not told what the final exam score is. That's what we're looking for. So that's going to be our variable. We'll just call it E here. So there is our inequality that we have to set up and solve. So first, if I take 0.4 times 86, that gives me 34.4. So plus 0.6e greater than or equal to 90. So if I want to get the e by itself, I need to subtract that 34.4 on both sides. So these cancel, and I've got 0.6e is greater than or equal to 55.6. So divide by 0.6. And you should end up with e is greater than or equal to 92.6 repeating. Now, when you get scores, you usually do not get a score that says 92.6 repeating. You get an actual score written on it, a whole score. So if the student just got a 92, it wouldn't be enough. And you know that because if you plug in 92 for E here, you end up just short of 90. So that means that really, if we're dealing with whole numbers, that the student needs to get a 93 or better. So you can either write it that, or if you just simply want to write greater than or equal to 93, that would work as well. And that is it for this lesson.